You can start. I really enjoyed it.
Morning, parents. Today we are going to demonstrate on the topic dancing popcorn. Please, can I ask you a question? How do popcorn kernels move up and down in water? By the end of the experiment, you will know how popcorn kernels move up and down in water. Vinegar, baking soda, spoon, cup, and water, and popcorn kernels. First, we pour water Okay. The baking soda. Put popcorn kernels into the
Tell us observation. George, tell us observation.
The popcorn kernels rise to the top when arrows attached to go back down when the arrows burst.
Sit down, tell us.
Conclusion. Loud voice.
Conclusion is the reaction between vinegar and baking soda produce gas, and the bubbles make the popcorn kernels move up and down. Good morning, parents. My name is Christiana Yahweh. My experiment is egg flotation. Please, may I ask you a question? How would you know that the egg we are about to cook is good or bad? Here are some eggs. Please, can you make a good egg? At the end of this experiment, you know which one you think is good or bad. So the materials needed are egg, water, and carbs. So first you pour the water. And put the egg slowly into. So please, what do you see from the experiment? So I see one egg is floating and another egg is sinking. Conclusion. The good egg sinks to the bottom of the cup. The bad egg floats to the water. This experiment helps us to tell whether an egg is fresh or cold. My name is Fifi. Today we are going to demonstrate on our topic, color working mixture. Please, can I ask you a question? How do liquid move through paper towel? The aim is to observe how color water mixes through paper towel using capillary action. Materials needed are 5 clear cups, food colors, and paper towel. Arrange 5 clear cups on the table and we pour our food color and we add our paper towel.
From the observation.
Observation is water travels through the paper towel. capillary action, and when colors meet, they are mixed to create new colors. So please, what do you see from the experiment? I see that the color was the full colors are meeting. Capillary action is when the colors are going up to when the colors are walking through the paper towel.
Alright.
Good morning, parents. My name is Emily Utinjaka. My experiment is sound vibration. Please, may I ask you a question? How do vibration produce sound? Materials needed are rubber band, clear frame, the speaker, and tissue. Tissue will be stronger, showing that loud sound causes greater vibration of the eardrum, and they show
talk loud, okay? We have to comport ourselves, eh?
Okay.
So who are those starting? Group 1, okay.
Good day, parents. Welcome to Science Station 1. My name is Erela Frank to my Betty Violet. I'm Andreas Kofi Roxon. The title of our experiment is Demonstrating Osmosis Using Air. What is osmosis? Osmosis is the movement of water from a region of high water concentration to a region of low water concentration through semi-permeable membrane. Question: how does salt placed inside the hologram affect the movement of water through osmosis? Hypothesis: if there is a difference in water concentration between the inside and outside of the yam, water will move through the yam cells from the region. Water will move through the yam cells from the region with more to the region with less water. Materials needed are fresh yam, salt, water, bowl, knife and spoon. Procedure: peel the yam and cut it into 2 equal halves. Scoop a small hole in the middle of each of the yam. Place salt inside the hollow part. Put the yam in a bowl. Contain water ensuring the water level is below the hollow. Leave it for a few hours. Observation: the water level in the yam containing salt solution rises. Little or no change happens to the yam containing distilled water. Observation: the yam containing the salt solution became soft after some time. Wow. The yam containing the distilled water remained hard. This happens because the water moves out of the yam cell into the salt solution through osmosis. Conclusion: the experiment shows that water moves through the semi-permeable membrane of the yam, through the region with high water concentration to a region with low water concentration. Thank you for supporting us. to an egg if it's placed in vinegar. Hypothesis. If an egg is in vinegar, the shell will dissolve and the egg will become smooth and bouncy. Materials needed are raw egg, vinegar, clear apple jar, and spoon. Procedure. Place raw egg carefully into a clear jar. Pour vinegar into the jar until the egg is full covered. Leave the egg for 2 or 3 days. Carefully pour the vinegar. Rinse the egg gently with water. Observe the changes in the egg. Observation. Bubbles appear on the eggshell. The shell slowly dissolves. The egg becomes soft. The egg may look slightly larger. Conclusion. The experiment shows that vinegar reacts with the eggshell and slowly dissolves. Thank you for coming. Good day, parents. Welcome to Science Station today.
My name is Jarly Kegan.
I'm Mariam Esther Daniels.
Today we are going to talk about solar system. The solar system is made up of the sun and the 8 planets that move around it. The sun is in the center of the solar system. It gives us light and heat. The 8 planets from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Mercury is the closest planet to the sun. Venus is very hot. Earth is the only planet that living thing can survive. Mars is called the red planet. Jupiter is the largest planet. Saturn is known for its beautiful moon. Uranus and Neptune are very far away. Each planet moves in a fixed shape called an orbit. Fixed path called an orbit.
Solar system. Conclusion. The experiment shows that the solar system is made up of the sun and the 8 planets that move around it in a specific order. The model helps us understand the arrangement and position of each planet in space. Space fact. These animals have all been in outer space. Chimpanzees, monkeys, dogs, mice, and guinea pigs. Venus spins backwards. On the planet Mercury, days are longer than years on Earth. At least 12 rocks from planet Mars have landed on Earth. On Neptune, the wind blows over 1,000 miles per hour. Earth is the 3rd planet from the sun. Earth is the 5th largest planet in our solar system. Thank you.
Good day, dear. Good day. Welcome to our science station. Our science station number 1. My name is Sabina, the one standing beside me.
My name is Zafira.
And the title of our experiment is Function of a Battery in an Electronic Device.
Question. How does a battery help an electronic device to work? Hypothesis. If a battery is connected to an electronic device, its power determines it work. Materials needed. Cardboard, batteries, wires, scissors, and marker.
Procedure. This is my electronic device. Look, does it have any battery? Now I'm putting battery inside. What did we observe? We observed that the device does not work without any battery. When we insert the battery inside, it will provide power and help it work. Conclusion. A battery stores chemical energy and changes it into electrical energy. This powers one electronic device and helps them to work. Thank you, parents and guardians, for coming. Hope you have a wonderful day. Going to the next science station. Hope they do well for you.
Good day, dear parents. Welcome to our science station. We are science station number 2. My name is Dora Francisca Nation. My name is Godroda Zimit. The title of our experiment is Dry Erase Magic Floating Drawing. Question: how does dry erase magic float on water? Hypothesis: if I draw with a dry erase marker on the smooth surface and add water, the drawing will float because the ink does not dissolve in water. Materials needed: dry erase marker, water, and a smooth plate. Procedure: draw a simple picture into the plate. Add water into the plate. Tilt the plate and see what happens. Tilt the plate and see what happens.
This one has removed.
No, it's removed.
The total. Dry erase removed. Yeah, and the filter.
What did we observe? We observed that the drawing separated from the plate and floated on the water. What was the science behind it? Insolubility and density. Insolubility: the ink does not dissolve in water. Density: the water is heavier than the ink. Conclusion: the marker is a mixture of ink pigment and alcohol. When you pour water on it, the alcohol dissolves and the ink pigment becomes a solid that slides on the glass when it gets wet. Thank you, parents and guardians, for coming. Hope you have a wonderful day with the next science station. Welcome to Science Station. My name is Adasa.
My name is Macho Elujimita.
The title of our experiment is Secret Message with Invisible Ink. Question: can we make invisible writing appear? Hypothesis: if lemon juice is write on paper and it is applied, then the hidden writing becomes visible. Materials needed: cotton bag, lemon juice.
Where is it?
Cotton bag, lemon juice, white paper, and bulb.
Procedure: squeeze a little lemon juice into a bowl. Dip the cotton bud into the lemon juice. Write a secret message on the invisible ink. Write the secret message on the white paper. Allow the paper to dry completely. The hidden message will appear. Carefully hit the paper near a bulb. The hidden message will appear. Observation: the hidden message becomes visible when it is applied.
We have our drawing on the paper.
Conclusion: invisible ink is made using lemon juice, and heat helps reveal the hidden message.
What is the science behind it?
The science behind it is lemon juice contains substances that changes color when it's applied. Thank parents
And guardians for coming.
Good day, dear parents. Welcome to
to our science fair. My name is Melissa. My name is Vicky.
My name is Liz. The title of our experiment is diffusion using potassium permanganate. Question: what happens when a potassium permanganate drop into water? Materials needed: transparent glass,
Why is it?
transparent glass or beaker, clean water, potassium permanganate, spoon.
Hypothesis. If potassium permanganate is placed in water, the purple color will spread throughout the water because the particle moves from a high concentration to a low concentration. Procedure 1. Fill the glass with clean water. 2. Put 1 or 2 crystals of potassium permanganate into water. Do not stir water. Operate. Observe the changes for several minutes. Observation. The purple color begins to spread in water. Conclusion. The experiment shows that diffusion occurs when particles move from a higher concentration to a lower concentration until they are distributed.
Small amount of potassium permanganate. Do not touch or taste it. Wash your hands after the experiment. Thank you, dear parents. Thank you, dear parents, for coming to our science fair.
Good day, parents. My name is Missionary Amwa. I am 7 years old. Today, we are come to talk about the experiment, some fun and cool science facts. We are starting from animal facts. Did you know that cows and horses sleep standing? Cows and horses can do this because their legs are able to lock and support their body, which helps them stay safe and escape from danger quickly. Cows and horses. This helps cows and horses save time and energy. So now, as you can see here, this is a horse sleeping while standing. So now we are moving on to the flamingos. Did you know that a flamingo can only eat when its head is upside down? A flamingo turns its long neck and head upside down to find food in water. Their beak is specially designed to filter food and plants from the water. As you can see, this is a flamingo eating with its head upside down. Did you know that ostriches run faster than horses? An ostrich is the world's largest bird. An ostrich can run up to 70 kilometers per hour. Their long and strong legs help them run faster across open lands. Now this is an ostrich over here. Now we are moving on to nature facts. Did you know that a cloud can weigh over 1 million pounds? A cloud may look fluffy and light, but they are made out of tiny water droplets that spread over a big area so they don't fall. Now we are moving on to the Venus flytrap. Did you know that some plants like the Venus flytrap are carnivores? The Venus flytrap has special leaves that digest the food for its nutrients. The Venus flytrap's leaves snapshot on an insect whenever an insect touches it. The Venus flytrap's food diet is insects. And the Venus flytrap has some teeth and a mouth which catches the insects. Another name for the Venus flytrap is called a snapper. Thank you.
Good day, parents. My name is Sunadeduri. I am 8 years old. The title of my experiment is Refraction of Light. The question for the day is, why does a pencil look crooked or bent in water? Hypothesis. When a pencil is placed in a jar of water at an angle, the pencil appears bent due to the refraction of light. Materials today for my experiments are a jar, water, pencil, and a torchlight. Let's look at our steps. Step 1. Fill a jar with water. Observe that the pencil looks slightly crooked or bent in water because of the light from our eyes, but in the air, fitted. Conclusion: we can demonstrate the phenomenon of how light changes direction from one medium to another.
Good day, parents. My name is Mabna Sawa Otu, and I am 8 years old. The question for the day is, how does a pinhole camera demonstrate that light travels in a straight line? Hypothesis: if light is produced from a source, light travels in a straight line when it until it is blocked or reflected. My standard for my experiment is flash torch, 3 pieces of cardboard, and ruler. Procedure: cut a small hole in the center of each cardboard. Stand the cardboard upright in a straight line. outline. Shine the flash torch on. We can see that the light is showing on the board. Observe what's happening. Slightly remove one card most out of the line. You can see that when you remove one cardboard setting, I really see the light on the wall. Observation. Light travels in a straight line and light passes through when light is in a straight line. When the light is not in a straight, it doesn't pass through it. This shows that light passes in a straight line. Conclusion. Light travels in a straight line. It only travels in a straight line when it only change direction when it's only blocked or reflected. Thank you.
Good day, parents. My name is Kumba Rotti, and I'll be representing the experiment electrical circuit. My question for the day is, what is an electrical circuit and what happens when the circuit is broken? Hypothesis. If the circuit is completed and properly connected, electricity will flow through the wires and the bulb will light up. The parts of the circuit: battery, switch, bulb and wires. Functions of the parts: battery. It gives electrical energy, which stores chemical energy and changes into electrical energy. Wire. It carries electricity from one part to another. Switch. It controls the flow of electrical energy. This is a switch. This is a battery. This is a wire, and this is a bulb. It uses electricity, which changes into light and heat energy. How to connect a circuit? Step 1. Connect one wire from the positive side of the battery to the bottom of the bulb. Connect another wire from the side of the battery to the negative side of the bulb. This is the positive side of the battery. This is the negative side of the battery. A broken circuit. This is a broken circuit. A broken circuit. If the circuit is broken, electricity will not flow through the wires and the bulb will not light up. Completed circuit. This is a completed circuit. If the circuit is completed with closed parts, electricity will flow through the wires and the bulb will light up. Let's switch on the bulb to see. Observation. We observe that if the circuit is completed, electricity will flow through the wires and the bulb will light up. Energy transformation for this circuit. It starts from chemical energy, which changes into electrical energy and changes into light and heat energy. Conclusion. We conclude that electricity flows through a complete circuit. Electricity flows through the wires only when the circuit is completed and the switch is turned on. If the circuit is broken, electricity will not flow through the wires and the bulb will not light up. Thank you.
Good day, parents. My name is Sia, and I would like to tell you about the Scarlet Water 96 train. which demonstrates capillary action. This is the process plants use to cool water against gravity. We start by placing a tissue into colored water. You can observe that the dyed water is traveling through the sand, which are like internal transport tubes through the leaves. Hypothesis: the lettuce is placed in the container of water mixed with food coloring. Then the dye will tint the leaves within 12 to 24 hours. As you can see over here, our leaves here have been turned into different types of colors. We use lettuce, and then we use ficus plant. Here are the ficus plants, and here are the lettuce. Here the lettuce, the edges have been tinted into a different color. The blue, as you can see here, it has turned blue. Here, the ficus plant, you can only it will not tint the leaves as faster as we wanted, but we can still see a little bit of color here. The same thing happened to the yellow, the dyed water with yellow food coloring. It looks like orange, but it's actually yellow. Here, the yellow will not show, but it will show that the leaves have become a little bit brighter. And here the red, it has been the leaves inside the red food coloring has absorbed more water than the rest of the plants. Conclusion: the colored water travels up the stem and tints the leaves. This visually provides that capillary action sticking leaves. Good day, parents. My name is Namuelo, and I have designed a working artwork that visualizes double circulation. The materials needed are vinyl tubes, syringes, food color, and cardboard. Hypothesis: if the syringes are pressed, the colored fluids pass through the tubes and demonstrates how oxygenated and deoxygenated blood pumps simultaneously through the valves. So this is how it works. Conclusion: the experiment was successful, and that the heart is a circulatory system. Using the syringes to create pressure, it shows how the heart maintains two distinct loops. Thank you.
My name is Mabina Adebayo Shansa. The title of my experiment is How Soil Type Affects Plant Growth. We have demonstrated which soil type best support the growth of crops. You can observe that the loamy soil is the most suitable soil for growing crops. The corn planted in the loamy soil grew taller and healthier than the corn planted in the vinegar-infused soil and the clay soil. My co-scientists will proceed to test the pH level, moisture, amount of light each soil receives.
Good day, parents. My name is Reverend Anawa. Please, allow me to identify the soil types. Loamy soil, Play yo-yo. We are huge yo-yo. We are going to use yo-yo tester. Thank you.
We are testing for moisture, soil pH, and light. First, we are testing for moisture. It's between 4 and 5. Moisture. If soil tester reads between 1.0 to 3.0, it means it is dry. If it reads between 4.0 to 7.0, it means it is wet. Or if it reads between 8.0 to 10.0, it means it is dry. We are testing for pH. It is at 1. A pH greater than 7 is alkaline, and a pH and reading less than 7 is acidic. We are testing for light. Light. It is at 1. From 0 to 500 is dark, and from 1000 to 2000 is light. Any reading between 500 to 1000 means there is medium amount of light. Thank you.
Good day, parents. My name is Jonkona. Today, I'll be representing on a battery-powered tank. It is made from cardboard, bottle covers, battery, a switch, wire, straw, and a small motor. This project uses physics, engineering, and technology. The battery provides electrical energy which flows through the wires to the motor. The motor changes the electrical energy into movement, which causes the tank to move. The switch allows us to turn the tank on and off. The purpose of this model is to show how science and engineering work together can solve real-life problems, and how electricity can be converted into motion. It also shows how batteries can power a machine. Over here, I have my battery power tank. This is the LED light, the box I will use, the wires, the motor. You can see it from here. And these are the wheels. We used a straw and a toothpick to attach the wheels together. This is the switch. In this diagram, the positive side of the light is connected to the negative side of the other light, which causes the light to turn on. Over here we have the cardboard, the pieces we cut to make the vehicle. And here we have the motor wheel. These are how I connected the wheels to the vehicle. Over here, I'm coming to test how it moves. The vehicle for too long, and I left the tank on for a long time, so the battery is out of power.
science fair. In our science fair, you'll be looking at rainbow in a jar, 2 discoloration, and basketballs. Thank you, Amasi. We are diving into the world of Bupa. We're going to be looking at rainbow in a jar. We are diving into the world of different entities by creating rainbow in a jar.
Thank you, Amma. Thank you so much. And Elisa.
We have a big jar. We got a honey inside the jar. That's the cornfield.
Show us your jar. Show us your jar, please. Can you show us your jar here? A jar, that's it. The honey is quite heavy. Yeah.
And Robin
That's the full color.
color orange.
Right. Can you tell us what is inside here, please?
Cornfield.
That's right. Good job.
Cornflower.
Flower. That's right. Thank you. Alrighty, thank you so much. Alrighty. Now I'm going to start the procedure just like she has laid, but I want her to also tell us, what do you think, what will be at the end of it, our result or conclusion that we will get?
Layer liquid different densities.
Thank you so much, so much. So we are going to also show it as well, just like the children have mentioned, and to see, is it exact of what they have said, or maybe it's a different way around. So we're going to do it as she started saying. We first have our jar, and we are going to first pour the heaviest density, which is our honey. So first layer, our corn syrup, mix it with the food color blue. The food color blue, just a little drop. A little more drop. Okay. Then we'll mix it to make sure we have the color that we want to have. Drop it down, gentle. Okay. It's a little bit thicker. So we want to make sure we have our layers. Who can tell me what is the next layer? Liquid soap. Wow, you remember. So that's the next one. We would love to use this liquid soap to do the next layer. Also gently slide by the side of the jar. Who can tell me what is the next one? Orange, and that is going to be the water. Okay, so we have the water and the food color orange. We pour the water to a certain measurement. Make sure we get our layer out a little bit. It's a little more So we're going to pour it back a little. And a little drop of food color orange. And also a little bitty drop. Make sure we get the orange color. But we need, what color do you think we need?
Orange.
Orange, so it should be a much deeper. Yeah.
Look at the orange.
So we have now the layers right here. We have the brown, which is the honey. The blue is what? Corn syrup. And the what? The green is what? Liquid. And then the orange is what? Food color orange with water mixed up with it. So now let's move on to the next one. Who can tell me what is the next layer? It is what?
Cooking
Oil. Wow, okay. Wow, that would be good. You know what? Which one that would do? So we add our cooking oil. Slide it by the side. Which is the
hand rubbing alcohol.
I cannot hear you.
Hand rubbing alcohol.
The hand rubbing alcohol. What food color should we mix with it?
Red.
Say that again.
Red.
So we're going to take our hand rubbing alcohol. Also pour it inside a plastic cup right here. Please put that down. So watch how Miss Selena takes it in. Okay, now we gently put it in. Please fold your hands and let's pour it in quietly. Also by the side.
Sit down.
It's large.
Until we get all the drop in. All.
Don't touch anything.
Yes, out. That's what. Okay, now we are going to let it sit, and there you see the layer. But immediately you have to cover it up, because what can tell me what will happen if we don't cover it up? Sure.
No.
Something you should observe what will take place here. So we are done. Thank you. So this is our rainbow in a jar. It's laying out. Do you see the layers?
Yes.
Do you see it? It's still laying out little by little. Before you know, the hand rubbing alcohol will be all up there. It's not mixing, it's laying out. Do you see it's laying out nicely and neatly? Wow, that's so beautiful. That's so beautiful. Good job. Thank you. All right, let's come right here. Ooh, tell me, what are you doing? Then stand up and please quickly give us your introduction. Huh? Yes, please.
To discoloration, when it changes to colors to white, yellow, brown, green, blue, black, and any color changes to discoloration. Thank you,
Thank you, Jesselyn Watson. Please have your seat. Beautifully well explained. The next one is Akomita. Could you please tell us some of the food that causes tooth discoloration, please? Can you mention some food that causes tooth discoloration? Louder, please. Okay. Caffeine, okay. And that is our lay here. Coca-Cola, okay. And water. Well, we will talk more about that. I'd like to also ask, Antoine, can you mention materials needed when you are experimenting to discoloration, please?
We have toothbrush, we have toothpaste, we have cheese, we have gloves, and we have chocolates, we have Coca-Cola.
Who can tell me what is it in each of the drinks here? Yes, please, commenter. Eggs, yes, and they are boiled eggs. Which one of these drinks causes a stain on your teeth?
Coke, caffeine, and tea.
Okay, Coke, caffeine, and tea. All right. So now we are going to, it has already been done. We are going to give it more time for it to soak and see which one will cause more stain and which one has no change at all. What do you conclude on this? Tell us your conclusion, please. So we conclude that caffeine causes more tooth discoloration on our what? Teeth.
How to turn carbohydrate in food.
Thank you so much. Wow, explain. Good job. What is starch? Yes, please. Yes, Kofi de Benon.
To take
What is starch? Starch is what? Starch give us what? For our body. Energy, that's correct. Give me high five. Who's that? So basically we are talking about the energy we get from what? Food. And how can you test it? How can you know this particular food I'm eating, there's energy in it that will keep my motor running? Okay? How do I start? Or first mention the materials. Let me hear the materials.
banana,
Okay?
bread, orange,
Okay?
walnut.
Granite? That's good. And what color? What color shows that, oh, this food has carbohydrate? It's what color? Yes, Lemon. Thank you, dear.
Blue or black?
Blue or black is right. Thank you. And then what about if there is no carbohydrate? What color will it give? Yes, please.
Yellow and brown.
Yellow and brown. So now let's do the testing right now. What is the name of this? I don't know. Can somebody tell me? Yes, Lemon. Miss Alina saw this and she have no idea what that is. Who can tell me? You don't know too? Are you sure?
Honey.
Are you sure? It looks like honey. But are you sure? What is that? Do you remember iodine? Iodine what?
Iodine.
Solution. You are right. Iodine solution. So we're going to use the iodine solution with our what? Special what? A dropper. So we're going to take a little. This is what will shows that there's a carbohydrate in it or not. So now we're going to put a little to see if there's a carbohydrate in it on the cassava or not. What color has it changed into?
Black.
So is there carbohydrate in cassava?
Yeah.
Oh, I see. Okay, now let's take a little bit of the dropper again. Please can help me here. Okay. Let's check the orange. What is this? Who can tell me what is that?
Orange.
Let's see. Will it also give us maybe black? Maybe. Let's see.
I see a little bit black.
What color is that? Now look at it carefully. Yellow. Is there carbohydrate in it?
No.
No, you're right. Okay, let's go to the egg. Okay, there's an egg. We're going to slice it. We have the egg. We have the what? I've divided into what? 2. So watch here. Class, what is this?
Egg.
Boiled egg. Is it uncooked egg or it's boiled? Boiled egg, that's right. So let's put the rest back in here. And then put a little dropper right there. I'll take a little dropper. Okay. And then watch here. Eyes here. Whoa, what color is that?
Yellow.
Is there carbohydrate in it?
No.
No. Okay. What about the groundnuts? Let's take groundnut. A little groundnut. Maybe on the side here. So we're going to put this one aside here. And then put a little bit groundnut in here. Also, we get to see if it has carbohydrate in it or not, okay?
Black.
Does it have carbohydrate in it?
Yeah.
Also have carbohydrate in it. Oh, okay. Everybody sit up. We all love eating bread. We all love eating what?
Bread. Let's see the bread.
We should see the bread. Wow. Quite interesting. They want to see the bread. It's okay. It's okay. All right. All eyes here on the bread.
A little bit bread.
A little bit bread. Yeah, not too much bread. Okay. Eyes here. Let's see. Let's see the bread.
Sit down.
Ah, boy. Okay. Oh, everybody. I know you all want to cut. It's okay. Please go sit down, everybody. I'm going to put a condom, little condom here, right here by this side here, and then shift here. You have eating condom. Wow. Actually, it's what we use that to make a banco out of it. So eyes here. Look on the condom. Don't bring. Sweetie, lift up your head, okay? All right. So we have find out which of these. Let me ask you a question. Which of these food have carbohydrate in it? Look at it and mention it to me.
Yeah.
Okay. The what? The bread. Okay. No. Are you sure? No. The cassava. Correct. The condo, correct. Okay, any other?
Groundnut.
The groundnut, correct. Yes, correct.
Bread.
And then what?
Bread.
The bread. So now eyes on the Gary. So what is it? Does it have carbohydrate in it? Right. Let me ask you. Is there carbohydrate in egg?
No.
Is there carbohydrate in the orange?
No.
But is there carbohydrate in the peanuts?
Yes.
Is there carbohydrate in bread?
Yes.
What about the condo?
Yes.
Yes.
Good day, everybody. My name is Savina Nanaya Clela.
My name is Matilda Jimita, and my name is Mebabna Oti.
Today, we would like to present the robot we are building using the MRT kit. Our robot is a simple and motorized vehicle that is designed to move forward, backwards, and turn. Our robot is made up of 7 components, such as motherboard, left and right motors, wheels, battery pack, connecting wires, structural blocks that form the body parts and help it to work.
The wiring is what allows the robot to function properly. It acts like rods that carry electricity from the motors and other components. Our robot uses 3 main wires, red, black, and white. The red wire carries positive power to the motors and other components. The black wire acts as the negative connection that completes the electrical circuit. The white wire is the signal wire that carries instructions from the controller. Together, these 3 wires allow the robot to turn forward, backwards, and forward. Thank you.
Thank you.
A car and a car key.
And what is this?
It's a mini town.
So how does it work?
It moves fast.
Please, can you demonstrate the robot?
Wait, one at a time.
When is it? Please, which one is the car in front?
One at a time. Protecting it. Can't you turn around? You can turn around.
Okay. What are the sides you use to control it?
Backwards to move forward, and then forwards to move backwards.
Okay, let's see.
What allows it to move? So what if the car key was not inserted?
Then it won't move.
So can it work without car key?
No.
Let's see. Move back. Can you move forward? That's not move. So the car. Please, we need to have.
Go.
Be careful with it. Turn forward and move this.
Okay.
I think your mind
It's the caterpillars.
What if the caterpillar?
So what if there were no caterpillars?
It won't move. Ten.
Please, what does the motherboard does? What does the motherboard mean?
That.
What does it mean?
So what is your conclusion? What have you been able to observe?
What did you observe that both cars need batteries for the move? If there's no key, it will not be able to work. If there's no battery, it will not be able to work.
Also without the IR sensor. If we don't
Put the key inside, it will not be able to set. But if we have put something inside,
if we
and if something is coming,
if we remove the IR sensor, we won't be able to know if we have put the key inside or not. And it will know that without the IR sensor, if we put something in, it will not sense that what we have put in is will make it work or not.
and if we block them with the iron sensor, will not be able to tell us that, tell the robot that we have blocked the way. It will just bump into it.
What up? Maybe your hands is blocking it. If you touch it, see, it's not flying because it's not generating enough air for it to fly. So my hands can even stop it like that. See, it's not generating enough power for it to fly.
Oh, you're smuggling the thing.
Why is it not flying?
Because the battery is not big enough. And it doesn't have enough.
And it's heavy. So you told that to the camera. Why is it not flying?
Because the battery is not big enough. And it's heavy.
And it doesn't have enough power to let the drone fly.
And there are 4 propellers, so this cannot fly.
Cannot power all 4 propellers.
And it cannot power all 4 robotics science fair.
6.
We got to
Move from there. Sit here. Let's come. Did you come? Come, stand here.
Whoa.
It's okay. And then we have our colors too.
It's part of it.
Use this one. You spread it around. Wait. Take your time, Anel.
Let's come on. Let's clap and
Spread it around the floor. And touch it. Stop. It's small. Also spread it around the floor. Wait, don't touch it. Wait for a while and then take it off. You can also pour it at the middle too. Don't touch it.
Let it go. Ready? Getting another. Okay. All time. Ha.
And now pour the color inside. That's right. Wait.
You want to blow it so it's
There's no bubbles.
It is not a bad idea.
Amazing.
Amazing. It really is amazing.
This is amazing. It's circle.
Yeah. Around the circles.
Yeah. Yes. Wow.
Because of this
So what's the science behind this?
She's like, yes.
It's okay. Hello.
It's okay.
That is awesome. Look at Shella. I'm licking.
Okay.
Magic milk experiment. The milk contains the fats, and then the water will also contain the chemical reaction.
How you know what
We
I
also
know?
have the soap, which is the liquid word. And then the colors too, it's also ready to mix it to get maybe a rainbow color or maybe a different color. We also use the soap to clean. Stop. We also use the soap in it so that you can know the texture of the
This is the
the texture of the base. So this one is the surface texture. Then we also let it to be into the center of the brick, so that at the same time we can cause the food color to sprinkle around the colors on the plate. And at the same time, know that when the surface will cause the food color to it has the food color to move around the plate, so that we can get the results from it. And at the same time, it also helps us to know how we can mix up the colors together.
Wow! This is amazing!
It's okay, it's okay. Victory, put your hands to yourself.